So week 6, atomic structure, so we're gonna be looking at atom and periodic table. I've included, if you're working at home and need access to periodic table, this is just a file that you can have it. But I've given you one if you're here that you can keep here in your notebook to reference. Today's the 8th, so we're gonna look at the bell ringer. And all I have here is 3 things that you already know about the atom, atomic structure, or periodic table.
Three elements, periodic table.
Here's what?
3 elements, periodic table.
Well, of course. Does anybody know how many elements there are?
Oh,
Look at the numbers on the periodic table. What does yours go up to?
well, okay.
We'll look at this one right here. Mine up here goes to 114. Yours goes to 118. So we can say, or we say they're listed on the periodic table. We can say there's approximately, what did yours have, 18 or 16? 118. That little squiggly line is approximately, I think it is the shift in the 1 key, if you wanted to type it in, no, the shift in the key beside the 1. Approximately 118 elements. A lot of those are man-made. Anything else about the atom, structure of the atom, periodic table? Anybody know any of the parts of the atom? What makes up the atom? All right, atom is the building blocks of matter. So all matter is made up of atoms, even you. So put some metal mat and go back to modules. All right, we're going to do some notes. So if you want a paper copy, those that are here, I've laid one on your desk. If you do not want to fill it in on the paper, you can fill it in on the notes. And carry and submit. But remember, you may want to submit the blank copy just so it doesn't pop up missing before I get a grade in. So if you click here, I have the PowerPoint. I always have vocabulary listed. We don't really do anything with the vocabulary at this point. So I'm going to click here. And all right, if you were to do a search in the periodic table online, you would find many different ways that they would color code the periodic table. You can see them kind of white, black and white, like the one I have. You can see them like the one I have up here, where you got different colors that outline it. And there should be a key that tells you what each of the different colors are. If it's like this, the whole little square is colored, and there is a key here. It tells you if it's light blue here, it's a metal. If it's orange, it's a metalloid. If it's purple, it's a non-metal. If its symbol is written in black, it is solid. If it is written in red, it is liquid. And if it is clear, that's what that symbol means. It's white writing. And it is a gas at room temperature. So different periodic tables show things differently. So yours is just black and white printed copy, and so you wouldn't know which are metals, metalloids, and all that on yours. We'll be adding stuff to it as we go that might help you with that. So just to review, hopefully at some point in middle school you had information about or whatever the periodic table. I can't remember if it's 6th, 7th, or 8th grade, but it's one of those middle school grades. So atom is actually the smallest particle of an element. We also call it the building block of matter. And it's going to have all the properties of whatever element it represents. So an element is the simplest form of matter. An element will be made up of multiple atoms that are alike. So water, we look at it simple here, water is a compound. It's going to be made up of more than one element. It's going to be made up of 2 hydrogen atoms, or atoms of the element hydrogen, and 1 oxygen atom. And we're going to be learning how to recognize and read these symbols like that. So you've got to be able to know from the symbol what makes up that compound. So just to get a little background of the discovery of the atom, we can't see atoms at all. And so back in 400 BC, this guy Democritus sort of came up with the term atom. He was a Greek thinker, philosopher, and he was thinking about matter, and he, I think, was the one that said if you kept dividing or cutting something and kept cutting and kept cutting, you finally get to the smallest piece, and that was an atom. And so that's Democritus. And then notice not a lot of information about an atom went on until about 1803. And then we have John Dalton. And his idea of an atom was that it was a sphere, and it was solid, and you can't get any smaller than it. And he said that elements are made up of atoms that all have the same mass, and compounds of atoms are atoms of different elements combined. So he started thinking along the right lines in that an element is made up of all the same type of atoms, and that compounds are atoms of different elements combined together. So he's getting there. His idea of a model wasn't quite right, because he said it was a solid sphere, like a teeny, teeny, tiny little marble that's really, really small, and you can't get any smaller. Dmitry Mendeleev is an important name. In 1869, we had all these different elements that we knew about, and he decided to try to organize them. There's got to be a way that we can access that information easily, and so he developed the first periodic table of elements. He actually organized it by atomic mass, and we'll find that was off just a little bit. It didn't actually organize everything, but he gets credit for the first periodic table of elements. Everybody good? Mm-hmm. And then in 1904 is when we finally get down to start figuring out exactly what an atom is. J.J. Thomson, he has what we call a plum pudding model. He was from England, and one of their desserts is a plum pudding. And so he said that an atom is divisible. So you can divide it into smaller pieces. But he said that the sphere that Dalton came up with was positively charged, and within that sphere, there are these negative particles that are embedded, kind of like a plum pudding. So you would have this pudding, and it would have chunks of plum in it, and so those chunks would be the negative particles, The pudding part would be the positively charged stuff. And so still, he knows that there's positive and negative parts of it, but that's about it for Thomson. Then, about 7 years later, Ernest Rutherford does an experiment with gold foil. He shoots some, I think it's beams of electrons of gold foil, and he determines that the mass of the atom and its positively charged particles are in the center or in a nucleus, and with that low mass negative particles around it. Because if you're shooting electrons, which are negative particles, it's going to bounce off of areas that have a positive charge. So all of the positive charges are clumped together in what he called the nucleus, with the negative charges around the nucleus. So we're getting closer to the idea we have today. And then we get to Henry Moseley. He actually discovered that the protons that are in each element is unique. So if you change the number of protons, you get a different element. And so he termed this the atomic number. And he's the one that then arranged the periodic table by atomic number. And once he did that, all these elements in this arrangement we have kind of fell into place by properties that we're going to learn when we talk about the periodic table. Also in the same year, this fella Niels Bohr came up with kind of a drawing of the atom. He said that electrons, which are the negative particles, actually travel around in a fixed orbit, kind of like this picture here, kind of like the solar system with planets, and that the nucleus has protons and neutral neutrons in it. And so there was a scientist somewhere in here that actually discovered the neutrons. And then we had more recent, in 1926, Schrodinger and Heisenberg developed what we kind of follow now is the electron cloud model. So you've got this nucleus, and you've got this cloud that's around it, and this is where the electrons are. They're kind of divided into shells, which are kind of like levels, but they're not necessarily fixed. They can, based on if they lose or gain energy, they can bump up and down in different shells or levels. So the orbits aren't fixed. So that gives you sort of some history of the atom and how we kind of came about to the idea that we have now. And these are like complicated experiments that they would do where they would have to draw based on observations of how electrons behave with certain materials, because you cannot observe an actual atom. So, parts of an atom you need to be familiar with. Nucleus is in the center. It's the most dense part. It is where you find your protons and neutrons. Protons, positive. Start with a P. Neutrons, neutral. Neutrons, neutral. This is the mass. Protons and neutrons are basically the same mass. And so that's what's going to create the mass of the atom. Now in the cloud is the electrons. So you can find electrons in that space around the nucleus based on energy. hence the energy levels or energy shells. And that region, you'll see the term shells and you'll see the term energy levels. So when you, if you go to community college or college, you will find when you take chemistry, you'll actually learn more about the shells and things than we would do here in physical science. Electrons that are further away from the nucleus is going to have the most energy. All right, electrons that are furthest away from the nucleus has the most energy. They're the ones that are going to be involved in making compounds. The electrons that are in the outermost, highest energy area, we call them valence electrons. Very, very important. Valence electrons. Negatively charged. Protons start with a P, positively charged. Neutrons start with nu, Neu for neutral. Electrons are negatively charged. And this is where the volume of the atom is. So if you're asked a question, where would you find most of the mass? You would say in the nucleus. If you're asking about the volume, the most space, you're talking about the electron cloud. All right, so we also call these particles subatomic. Sub meaning below or lower, and atomic meaning atom. So here's how we usually abbreviate proton, with a P with a plus sign. So it's positive particle in the nucleus. Neutron we usually represent with N with a 0 for a power. And that's the neutral particle. They live with the protons in the nucleus. And the electrons, this is how we usually abbreviate it, E with a minus sign. They're the negative part, and they're going to be outside the nucleus in the electron cloud. You get all that, Amaya? Then we're going to briefly talk about what holds the atoms together. And then there's an online activity that we're going to do, and I can print the a hard copy of that sheet for you to fill out as well. So let's see if I can get that up while some are finishing. All right, we got that almost. All right, the last part. Forces. So there's something called an attractive force. An attractive force is what happens between opposite charges, positive and negative. So they're going to attract each other, so it's an attractive force. And so this is one of the forces is holding the atom together. So then you also have kind of a repulsive force, and that's between electrons. So negative charges are not going to want to attract each other, so they're going to want to be as far apart from each other as possible, hence the volume of the atom. And repulsive forces also happen between protons as well, because remember they're compacted together. And so like charges are repulsive, they repel each other. And so they want to be as far apart from each other as possible, but it's to keep them together in the nucleus, there's a lot of energy that's holding them together. And because they've got to be compacted together more closely. And so neutrons kind of play a part in some of that, because if you have equal numbers of protons and neutrons, as we're going to find out, they're going to be more stable, the nucleus of the atom. So, if you did this online, when you get these filled out, you submit it. If you did it in class, just make sure it gets in your notebook, and I'm going to make note to give you your credit. And while you're finishing that up, I'm going to slip out and grab the papers on the copier for the next activity, in case you want to do it on paper, it might be easier. I want to give you a sheet of what we're going to do next. You may decide you want to do this on paper, I don't know. Did you do your notes online? Okay, you submit them. Okay. It's going to be the next thing in the module. There's a website that has some online manipulatives, and it's called ChemThink. And so we're going to go through the one for atomic structure, and you're going to answer questions as you go through it. And this is kind of our practice for this. And if you get this completed before the end of class, then you have time to work on some makeup work. Remember, everything's due February 12th. So if you go back into modules, so you will need your computer for this part. Right here where it says ChemThink atomic structure, you're going to put, oh, I didn't change the date. I will change that. Don't worry about the date there. Right here is site, and I would, in case it doesn't open in a separate link, always press Control when you click it and you get it to open. Sometimes it will open automatically in a different link, and sometimes it doesn't. And this is why you may want to do it on paper, is because you have this nice little online activity here. So you're going to see this when you click on that link, and you're going to click on Launch. So everybody needs to go through and get to that point. And when it launches, you're gonna have this big area. And the thing is, you're gonna want to actually read through this, and you're going to press play as you go through this arrow button here, as you go through. And then you're gonna answer these questions as you come through it. So this first part is just giving you, it's kind of an overall, we're gonna take looks at the parts of the atom and learn about their properties. So you're gonna click here, and now you're gonna follow these directions and answer these questions as you go along. And so if you get stuck, just let me know, but that's what you're gonna do. And so as you go through each thing, you should ask, and then there's something where you're at the end, you're completing a table, and you wanna make sure you write in the information in that table at the end. So you're gonna work independently. If you have a question, ask me,